Oh, right, that's now, I suppose, stage 2. The strip board's got all the required cutouts, I hope. I've not missed anything. And the next stage then is to fit the sockets and whatever. I mean, put them in there to hold the 2 strips together, because I'm using long pin strips for those. But I suppose up to now, it's no different than if you were building it by any other technique. You could equally put conventional IC sockets and discrete resistors in the appropriate positions and solder it conventionally with wire links. But now using wire wrap, this is where it gets a bit different, because using wire wrap socket pins, the pins on these are about 0.7 inch square, which is a standard that's been about for decades. I don't know exactly when it was introduced. Technically this isn't standard, this isn't wire wrap, it's mini wrap. The original wire wrap pins were about twice as big. They were massive flat things, probably about 1.5 mil wide each, and using quite a bit thicker wire than this. But this is the only one that's generally used nowadays, and it's the only one I've ever used for anything I've built myself. At least I've used and worked with it a bit on other things, but you know, the original style. Anyway, if I stop waffling and start fitting things, that should go somewhere around there if I've got it right. No, it's too high, I want to be one hole lower. There. That should hopefully line up with all the cuts, yeah. I've put a section that's got all the pads cut out, all the copper cut out, between each pair of digits as a marker, and each digit's got the centre bar left in place, because the top and bottom centre pins are both the cathode. It also helps just keep a track of which pin you're on when you've got all the continuous line of pins. So that's the display. That's the pull-up resistors, or pull-up and pull-down resistors, whichever they are, which are going somewhere down here. The 4th hole in and 4th hole up to start. So hopefully that's that one. Yep. And there is the 330 ohm 8 separate resistors. And you can actually, the lighting's a bit wrong for it, if you've got a light behind you can actually see through. That's going to be that one there then. The pads that have been cut away, I think just about see if you get something behind it. The pads that have been cut away, you can see the lighter, because the copper's gone around the edges of the holes. So if you've got a light behind it, you can see quite easily which ones you cut away, which positions you're putting things in. And somewhere on here I should have, yeah, there we go. That's that MIC for the driver, which looks like it could be that one. See if that's all correct. Yep. And then finally there's a 40 pin socket. Well, not quite finally, but for now. It's a 40 pin socket, which is where the microprocessor modules go in there, blue pill. Yeah. And the push button switches are going on the bottom. Now these, if you've never used these, the 2 pins there are connected together directly. 2 pins there are connected together directly. The switch is between the top and bottom rows, if you like, not the side to side ones. At a glance you'd think this the side to side, the 2 adjacent pins of the switch, the 2 adjacent pins are connected and the switch is end to end, but it's the other way around. So putting them in that way doesn't give me much space, because I want a bit of space around the bottom if we put this in an enclosure at any time. So they're going in side to side, which means they've got to be well spread out. I think they're going about there. a little bit on the tight side for this one further across. Let's see if they fit. The pins will go through 1mm strip board or matrix board or whatever, but they are just on the verge of being too tight. They need a bit of persuasion. Can help to actually straighten them first, because they've got the spring and kink to help hold them in on the oversized holes. I think that's it. The last pin should be, yeah, they're right. So it's now actually just pushing them in. Just give them a bit of a press and a wiggle and persuade them to go in. Just don't try and force them in too hard in one go, or else the pins can kink where they're bent. They'll have buttons on top. They've got various forms of switch caps. There's got multiple different types. There's round ones, there's square ones. You can also get these that have got taller plungers. So if you're going to put them through a panel, you can use a cap that's spaced away, more like the line of whatever else components they're fitted with. Anyway, that's the bulk of the stuff. What we've still got to go in are the segment driver resistors. On the right sheet, that's those there, and the transistors. The resistors for the transistors are part of the arrays, but the transistors themselves have got to go in. I've cut some extra bits of track there, and I think I'm going to put the 6 resistors and 6 transistors and 4 of the resistors there, and there's just enough space here to angle in the other 4 resistors. Oh, I've just noticed that that's one of the things with this, this being a generic kind of strip board, the holes aren't exactly centered in the tracks. It's very difficult to see, but the holes are just offset slightly one side of the tracks, so it's a little bit thinner at one side than the other. So if you only just barely, what looks like barely cut it, you can cut the side it's closest to and leave in the other side. You can see the offset shape of these, it's kind of tapered. I thought it'd been round and done up at an angle to clear out the extra bits, but that one I think I'd missed it. And there was just a trace of copper still in that slot. Anyway, it's just a matter of keep checking over and inspecting things. Yeah, you can see there, you can see they've got a definite edge on one side because the copper strip's wider compared to the hole centre on one side. Anyway, that'll do. So the next thing to do, I've got to solder all those in. I'm not going to fully solder things where I don't need to. So, because when it's only being connected by wire up, the connection to the copper strip is irrelevant. It only needs soldering completely where there are all the components connecting through the solder. So generally, just tack them in, e.g. for like corner pins, possibly on a long strip like that. Might do a couple of others along it. I might use the spare pins again as markers. And it's just enough to hold things in. The switches obviously are being soldered because they're solder connections, and those 4 there are connecting the resistors directly to the pins are going to have to be soldered. But other than that, just the corner pins. So I'll go around all those and carry on when they're done. Oh, the other thing is I wouldn't generally do it with the parts in, but one thing with these displays, it's something I'm not used to using, and they're odd pinouts, and I want to hold everything in place and hold them in line because they're separate pins, separate strip pins, and they can wobble. And the other thing is just partly so it's clear what parts are going in where. But some of these are going to fall out unless I use some padding to hold them in. Just put that on the back. That'll kind of level things out so I don't lose bits or they start coming partly out and end up stuck at a silly angle. Ah, I've missed cutting that completely. That needs cutting down the centre of that one. So otherwise these are going to be connected directly together, which they're not supposed to be. Tends to get to my eyes after a bit. I've got a dry eye. I've got a little fan lashed up, just an old PC fan, 12 volt one. This particular one happens to run quite nicely, but slow and quiet on 5 volts. So it's got a USB cable spliced on it and plugged into the USB power supply. It's a bit dusty, but it just causes a little bit of air movement that disperses the solder fumes rather than going straight into my face when it's stood at the side of the bench there. So they're going sideways rather than towards me. So that's the basics of the parts assembly, the sockets assembly. Now, I did leave some vertical runs of continuous strips for ground and power. And what I normally do when I've got copper strips usable for ground and power is connect directly with solder bridges to the relevant pins. Now, there's not many that's going to work on this, I don't think. Because that's not a normal TTL IC, it's this MIC 5891. That doesn't have corner power. That doesn't have corner power. The only thing it's actually got to apply to, really, is that, because I put the commons of the resistor packs at positions 8 and 16 on the 16-pin socket. And there will be a ground common along the entire bottom of this, because they're all going to be grounded on that side of the switches. The others will go to the pull-ups. So there's 1 or 2 more bits of soldering to do on that, but not a lot. In fact, it's hardly worth bothering trying to bus them to power. The only thing is having known power bus strips allows you to do is have somewhere to put power wires on and take the various power links back to make it easy in wiring, because you don't really want to daisy chain power all the way around every possible connection on the board, because, well, there's one thing is if you have to change anything, you've got to redo a lot of wiring. And the other thing is the resistance is going to get progressively higher, and you're going to get more noise and more voltage drop. So you're better taking each IC to its own ground and power at the nearest heavy connection point, rather than just daisy chain all the way through a number of points. Right, so thinking. Right, the switches are low current, so I can use a bit of wire for those. Find an appropriate pair of cutters. I did have a pair of cutters here, honest. I've only got about 15 pairs here. Looking for an orange handled pair which are particularly good, and these aren't too bad. Now this stuff does strip quite easily with sharp cutters. You can just grab it and pull the insulation back. So there we go. Now that's one thing that's useful for doing long commoning links. The other thing is, which I'll probably end up doing on here, if you're trying to do very, very short links or point-to-point connections, trying to get that to strip the end after you put one end in, it can be rather difficult. And so I'll show you a trick with that as I work through it. But, we'll just common those all up. Oh, yeah, that there was going to be that vertical track was going to be the ground bus. Yeah, and that one there is also ground. So those three can be linked together. Try not to stick my head under the camera and obscure things. Right. And one there can be another ground as well. So that's the bottom side. That's not a really joint there. That's the bottom side joint on each of the switches connected to ground. And the top pair of pins will be the output, or either one of the top pair of pins will be the output. Okay, wiring time. Or at least start. I've got to put all the other discrete components in yet. There's 8 segment resistors and 6 transistors to go in, and probably a couple of capacitors. Wiring routing, I'm going to either be going straight through and around that end, or out and around this end, and trying to avoid routing anything straight through the middle. I like to keep them in blocks. Now I could go there, there, there. I mean, if I've got one of the boards, try and keep all the wiring in as far as practical. Obviously those I have done because they're memories, and there's nothing else, no discrete components in the way. But you can see to some extent there it goes in kind of defined paths, bus paths, and avoids other areas rather than having it just as anywhere point to point, which gets extremely messy and it's a lot harder to fault find or trace through later on. Right, wire. Oh, that's some RS stuff, modern stuff, 50 meters, and it's a silly price now. It used to come in 500 meter rolls to fairly trivial price. I mean, this roll's probably like 30 years old. I don't know if that's RS or Farnell's or something, but one of the big suppliers. You see, it's a very small core, and although it's been in use for years, there's still quite a lot on it. It's still heavy. The cheap stuff now comes from AliExpress on China. This is a typical roll from them. That's another black one. You see, it's a large core, but there's a fair weight to it. It's 1,000 feet, so it's about 300 meters, or 330, is it, something like that. So this isn't too bad a price. I got a pack of assorted colours. It does seem to be a little bit thinner, possibly, than the official stuff, if you like, but it works okay. So I'll be using some of that. I'll use 3 different colours for different things. Sometimes I do everything the same colour, but you can see on some of the other boards. It's a microprocessor board, but they probably use different colours for data address control. So again, it just helps a little bit with debugging or checking things through, because you can see what each group of wires or group of pins in an IC is for by the wire colours that are used on them. Right, so I'll do the cathode side wiring in black, the cathode wiring in black, I think, anode wiring in white, and general stuff in blue, if I remember. Might get fed up with it and change halfway through, or if this video ends up getting broken up and done over another few days, it's already been about 3 or 4 days, I might end up forgetting what I was going to do anyway. So that's the first strip. This is my favourite ancient tool. It's decades old. You see how it's fairly well worn. I've got a new one somewhere. What have we done with it? Oh, there. That's a newish one, which is from AliExpress again. You can see it's nominally the same. It's a fraction of different sizes, but hardly anything in it. I think it's because this is unworn and it's still got very sharp edges. It's a little bit stiffer to start the turn, and it can occasionally break wire, because it takes so much force to get it moving to start with it when you first start turning it around the pin. So I'll keep using this for now. There's less messing about. Right, well, the first thing actually is the bus wiring, which is going to be all internal to the display area there, which is to connect all the pins in parallel for all the segments. Now that's the pin out, which unfortunately doesn't give it directly. That's labelled in segments, and then the segments to pins and a separate map. But basically the pins 3 and 8, which it starts from there at the bottom, 3's in the middle of the bottom, 8's the middle at the top. That's the 2 I left the solid connection through. All the others need paralleling across all displays. So it doesn't really matter which side to start from. These blocks of 5s. Now this may be where the other technique I was saying about would have come in better. So that's got to go from that pin there to that pin there. So the insulation wants to be about 0.1 longer than the gap. So the insulation is about there where I've kinked it. So that's the cutting point. Doesn't matter if it's a little bit longer, because it'll just wind in before it starts biting and wrapping on the pin. I'll just pull the loose stuff in as a spiral around the pin. So as soon as I start wrapping, it should take up some of the loose. It just wasn't much there, but just about see it. That's actually a little, I was expecting to take up more than that. It's actually not a perfect joint technically, because it hasn't got a full turn of the insulation around the base. Oh, that's it. Technically, this is called a modified wrap, where it has a turn of insulation around the base rather than just the wire. With a bit of insulation acts as a strain relief. It's the commonest type, and it's the most practical one for a lot of things. And it's just the tool's got a bit of a recess in it, so the insulation fits slightly in as well, rather than just the wire. So that's then got to go to that one. There'll be a little bit more insulation on that one. That's better. It's got a full turn of insulation. It's a bit looser, but doesn't matter. I mean, electrically it doesn't make any difference. It's a mechanical and cosmetic effect. If you've got long wires in something that could be vibrating, then having the turn of insulation and strain relief can improve reliability over long term. But for something like this, it's very short wires, and it's not going to be undergoing vibration or in use for something critical, then it doesn't matter. As long as you're aware of it. That just slipped slightly there. I was lifting the tool and the wire started to slide out. So just set it back in again. Now this is going to be quite tedious because I've got to go along with 5 links for the joints between the 6 displays 8 times. So there's 40 wire links to go in here. It's probably quicker than the soldering anyway. You just need to somehow hold the wire before you start wrapping the first end. Otherwise it can just start winding in and end up spiraling around the pin in a big lump. This is probably one of the most awkward kinds of interconnections you can do, working along the same row of pins rather than crossways through pins like for memories. Oh, keeping this in the camera okay. That's 1 of 8. I don't know if I'm going to use the decimal points, but I may do, so I'll wire them in anyway. I don't even know which pin that is. Decimal pin 5. That bottom right one, looking from the front. Anyway. Having one row in, one chain in, should I say, as a marker, as long as you're sure it's right, helps put the other stuff in because you know which pin you're going to. You're going 1 pin along each time from the previous one. If you got that wrong and then started going one along all the way, you'd have a lot more to undo. So it is worth just double checking. Oh, missed. The insulation's got to go through into the little notch in the tool there. You start to see it when I can see it myself there. Might be better with a different colour white, but you can see that there's that little cutaway between the ferrule and the thin notch in the body of the tool, and the insulation goes into that, and that's what gives it the modified wrap. It just allows for that extra bit of insulation in the part of the wire that's been wrapped. Bits to tend to build up in the cutter, and once you get too many in there, they can start to mess it up, so it tries to tear rather than cut properly. Another thing you've got to be careful of once you start getting rows is that you're on the right pin, because they don't tend to all look the same when you're looking at them straight down the pins. As you can see, the stuff does strip quite easily. It doesn't need a lot of force. It's generally nice to work with. You don't have all the problems of insulation melting back. Get that in there. Get out of it. Yeah. You don't have the problem with insulation melting back and the bit of wire you tinned suddenly being a different length as you can with normal wire links, especially if you're using cheap thin insulation wire. Or trying to hold it whilst you're soldering if it's awkward or springy locations. So you can see for something like this, it's just quite repetitive, but as I say, it's also quite relaxing when you got to get into it. I'll turn the soldering off again for now. A while before I need that. You have got to get the wire down the tool correctly there. These bits are just about short enough to start getting awkward to get that last bit in properly for the insulation for that extra turn. Two down. I almost went on the next pin, but that's the cathode, so that's not used in this section. That goes to different individual drivers rather than the commons. Again, the nice thing with this compared to soldering is if you do put one on the wrong pin, you just unwrap it, either reposition it or throw that bit of wire out again and replace it, and there's no mess, no damage, no problem, no desoldering, which makes it very good for prototyping when you're not sure what the circuit's going to end up as, or you think there's going to be lots of changes. Because there's, again, no mess, and it's very easy, quick, just to keep changing wires around. It only takes a few seconds to replace a wire and put it somewhere else. And I mentioned a few things in the previous video I did outlining wire wrapping. And one of the other things with this is it gets more, the joints get better over time. There's so much force between the wire and the corner of each pin as it's pulled round by the tool that it forms a kind of small pressure spot weld, and those are so good that over time there's some level of molecular diffusion in them, and the contact resistance actually goes down. You know, it's almost as if the metals are gradually merging over time. Rather than being a joint between two metals, it becomes nearer a single piece of metal with two bits of different shapes sticking out of it. It's also very low capacitance, as long as you arrange it properly for high frequency stuff. It's very low capacitance compared to circuit boards. So I think I've managed to pull that one up at the base. It's very low capacitance compared to circuit boards because each wire is separate, and it's basically two other wires. It's aired electric. Obviously each connector's always got some inductance as well, but with less capacitance, any frequency effects would come in higher than with a circuit board track that have got the same length and high capacitance. One of the bigger boards would probably do permanently flat on the bench, but I'm trying to keep it a bit higher so you've got a better view of the camera, and also at an angle, so you're not just looking at the back of my hand as I'm working on it. That one's lifted a bit. Just push it back down at that end before I wrap it, so it holds into the rest of the first turn around it. Oh, that's three chains, 3 segments. So this is the last one on the top, or the last chain. resist the temptation to look further over it. So I just headbutted the camera slightly. Okay, where was that one? There. So there's a reason for sometimes using different mice for different sections. It allows you to identify things a bit easier. But these are all the same function. And, sometimes just do the entire board with one colour, depending on what I'm working on. But it can just occasionally take a second to figure out which connection you're going on to. Right now, there's that one. I think this is the last one for that top half. Right, that's one row. Okay, I'm having a quick break and getting a refill.